This early, chaotic ballet of destruction and creation is how our own Earth, and all the planets we know, truly began their journey. These planetesimals, now big enough to exert their own gravitational pull, start hoovering up everything in their path. The environment becomes incredibly violent, a genuine cosmic demolition derby. Picture countless proto-worlds, ranging from moon-sized to Mars-sized, hurtling through space, constantly colliding, merging, and sometimes, tragically, shattering into pieces. It's a furious race to grow, where only the biggest and luckiest survive. Some theories suggest these early growth spurts were incredibly rapid, forming protoplanets in just a few million years, while others argue for a more protracted, drawn-out process. Think of it like static cling on laundry day, but on a cosmic scale. These microscopic particles bump, stick, and slowly begin to clump together, forming pea-sized pebbles, then small rocks. It's like watching a cosmic snowball fight in slow motion, except the snowballs are getting bigger and stickier. But this isn't a gentle process forever. As these pebbles grow into larger chunks, tens or even hundreds of meters across, what we call planetesimals, gravity finally takes the wheel. This is the key scientific principle of gravitational accretion in full swing. Suddenly, the game changes. Okay, so we've got our newborn star, right? Surrounded by this swirling, chaotic disk of gas and dust, a protoplanetary disk, like a cosmic pizza dough waiting to be shaped. Now here's where the magic, or rather the brutal science, really begins. The birth of a protoplanet. You're now a tiny speck of cosmic dust caught in this turbulent nursery. At first, it's all about gentle bumps and whispers. Tiny dust grains, no bigger than a grain of sand, start to feel a subtle pull. Not gravity just yet, but the surprisingly strong electrostatic force. At its very heart, the pressure and temperature became so incredibly intense that our proto-sun flared to life, a blazing furnace ignited by the sheer force of its own gravity. While the supernova shockwave is our leading suspect, scientists still debate the precise characteristics of that stellar explosion and its exact proximity to our nascent nebula, adding a touch of cosmic mystery to our origins. As this immense cloud collapses, something incredible happens due to the principle of conservation of angular momentum. Think of it like a cosmic ice skater pulling in their arms. As they draw closer to their center, they spin faster. The same physics applies here. Our collapsing cloud, which had a slight rotation to begin with, spun faster and faster, causing it to flatten out into a magnificent, rotating protoplanetary disk, a cosmic pancake, if you will. This flat disk is where our planets will eventually form. Picture an ancient star, reaching the end of its life, exploding with the power of billions of suns, sending ripples of energy and matter hurtling through space. When one of these shockwaves slammed into our tranquil nebula, it compressed the gas and dust, just enough to tip the scales. Suddenly, you observe gravity, the universe's ultimate architect, begin its masterpiece. It starts pulling those scattered particles inward, ever so slowly at first, then, with increasing urgency, into a denser, collapsing core. Now here's where things get really fascinating. Welcome to the ultimate origin story, the birth of our very own solar system. Imagine, if you will, a vast, cold cloud of gas and dust floating silently in the cosmic void, our future home, but still just raw material. This isn't just any cloud. It's what scientists call the solar nebula, and its journey from peaceful slumber to stellar fireworks is nothing short of epic. You're watching as an unimaginable force gives this quiet nebula its wake-up call. Scientists widely believe that the catalyst for our solar system's creation was a cataclysmic event, the shockwave from a nearby supernova. We'll witness the moon's dramatic birth from a catastrophic impact, discover how water arrived on Earth, possibly delivered by icy space visitors, and see how simple, microscopic bacteria fundamentally altered our entire atmosphere. Scientists still debate the exact cocktail of comets and asteroids that brought Earth its precious water. But one thing is clear. It was a cosmic delivery service unlike any other. Get ready to explore the deep history of Earth's formation. 6 billion years. Close your eyes and imagine yourself floating in an immense, cold, dark cloud of cosmic gas and dust, the remnants of a long-dead star. This is the solar nebula. From these tiny specks, something truly extraordinary was about to happen. A star, our sun, would ignite, and swirling around it, planets would begin to coalesce. Our planet, a tiny speck among them, was destined for a violent, transformative journey. How did a scorching, constantly bombarded ball of molten rock eventually give rise to our deep blue oceans, lush continents, and complex life? What if I told you that the very atoms in your body might have once floated in the vacuum of space, part of a dying star, billions of years before Earth even existed? Pretty mind-blowing, right? If you enjoy content like this, don't forget to like and subscribe. It really helps the channel grow. Comment below where you're watching from, or tell us which natural mystery fascinates you most. Let's dive in and explore how it all unfolds. To truly grasp this epic saga, you have to rewind. Not 100 years, not a million, but 4. Welcome to today's deep dive into the very origins of our world. If you think the history books are thick, imagine trying to chronicle 4.6 billion years, a timeline so vast it makes the Big Bang Theory seem like a new release. We're not just talking about ancient history. We're talking about the fiery, chaotic, and utterly improbable birth of everything we know. It's a story of cosmic dust, titanic collisions, and tiny, invisible forces that sculpted our home.